Okay, good morning. Welcome back to Calculus 2. We are going to be looking at problem number 2a here, determining whether the series n was 1 to infinity of 3 over n times n plus 3 converges and find its sum. So the first thing, every time you see something like this, it's like, well, you might be thinking like, well, it goes to zero. Okay, yes, it goes to zero. But just because something goes to zero doesn't mean it converges. But one of the things you might want to do is think, well, could this be a telescoping series? Okay, so that's always a question you have for, especially when you have fractions like this. So what we're going to do is we're going to apply partial fractions to composition of this and see what we have here. So we have to go ahead and say, well, this is going to be a over n plus b over n plus 3. Notice there's just a degree 0 on the top. There's a degree 2 on the bottom. We're allowed to use partial fractions. We don't have to do division or anything like that. And we're ready to go. So we could say we have a over n plus b over n plus 3 is equal to 3 over n by n plus 3. I'm going to multiply everybody by n times n plus 3 because I don't like the fractions. Okay, so what's going to happen is these n's are going to disappear. So we have a times n plus 3 plus b. The n plus 3 has disappeared with this one as this whole term visits my n plus 3 here. It all goes, all the n plus 3s goes away. So we just have bn is equal to 3. The whole point of clearing the fractions was to make sure that the denominator went away. So we're going to say, multiply this out. We have a sub an plus 3a plus bn is equal to 3. Now, what I'm going to do is I'm going to equate the coefficients. I'm going to take all the stuff on the left that has an n on it, and I'm going to equate it to all the stuff on the right that has an n in it. So here on the left, we have a plus b equals what is on the right-hand side with an n in it. There is nothing with an n in it. So it's just going to be equal to 0. We're going to take our constant function. We're going to say, okay, we have 3a, that's my constant, is equal to 3. Oh, I guess a is equal to 1. So we can go ahead and divide both sides by 3. Once I know that a is equal to 1, well, from my first equation, it's pretty obvious that b is equal to negative 1. So another fancy way to write this equation, write this series, is to say this is the series of 3 over n by n plus 3 is actually equal to, what was my a? It was 1 over n, 1 over n, minus 1 over n plus 3. See, now I've got some minuses in here, so I'm looking at this like, aha, there might be a telescoping series here. So what I'm going to do now is I'm just going to start plugging in some numbers and see what happens here, see what cancels out. So at n equals 1, we have 1 minus 1 over 1. Just write it that way, okay? So we'll be consistent about what we're doing here. So we'll go ahead and we'll say 1 over 1 minus, and then n is equal to 1, so this is minus 1 over 4. Okay, and I'm going to go ahead and group these so I know what I'm doing. At n equals 2, okay, we're going to have 1 over 2, that's plugging it in here, minus 1 over 5. Okay, not yet. How about n equals 3? We might have to do this a couple of few terms to see what's going on. So it's going to say plus 1 over 3 minus 1 over 6. Okay, and that's my third term. How about n equals 4? So here we have plus 1 over 4 minus 1 over 7. At that point, there's a little glimmer of hope I have in my eye because I'm looking at some problems here and I'm thinking, huh, let's see, we'll use green. We'll say, look, I've got a minus 1/4 here and I've got a positive 1/4 here. Those eventually are going to cancel out. Let's go ahead and keep going with this little piece here because I want to know exactly how many of these are going to cancel out and what am I going to be left with? So that was n equals 4, n equals 5. We have 1 over 5 minus 1 over 5 plus 3 is 8. So we have this. And again, we can go ahead and cancel these guys out. So we have a 1 over 5 sitting over here. We grab this guy, and we have a negative 1 over 5 over there. Okay, and we'll just keep working with this. Okay, when n is equal to 6, okay, we have 1 over 6 minus 6 plus 3 is 9. And at that point, we can say, okay, we have the 1 over 6 here and the 1 over 6 there cancels out. Okay, n is equal to 7. So we have 1 over 7 minus 1 over 10. So here we've got, here's my 1 over 7. Here's my 1 over 7. Let me get rid of this guy. There you go. Okay, here's my 1 over 7 and my negative 1 over 7. Okay. N equals 8. This was n was equal to 7. And equals 8. We have 1 over 8 minus 1 over 8 plus 3 is going to be 11. Okay, so we go ahead and start canceling these guys out. So, oops, not that one. Leave that alone. That was 1 over 8. Okay. So this, no, stop doing it that way. I want this piece here and this piece here. At this point, I'm looking at like what canceled and what do I still have left, because I'm kind of getting the idea that all of these guys here are canceling out. I think if I just keep writing more terms that these pieces are also going to be canceling out, and then eventually we're just going to get them all. But these first terms, they're not going to all the way cancel out. So I've got 1 plus a half, let's see, plus a third. Let's see what we have here. Yeah, so we have 1 plus a half plus a third. Okay. Where are we? 1 plus a half plus a third. Where's my little chart here? Yeah, 1 plus a third plus a third. I think I have a minus 1/6 in here. No, I don't. We're just done with that. So we have 1 plus a half plus a third. We should have a minus a 6 in here. No, we're there. That's it. Yeah, 1 plus a half plus a third. Everybody else seemed to cancel out, and we're just going to go ahead and figure out what we have for this. So we could say 1 plus a half plus a third. So we have, let's go ahead and call this a 6. We have 6 as a denominator. So we have 6 over 6 plus, and here we have a 3 over 3. So we have a plus 3 over 6 plus, and we have a 2 over 2 here. So we have a 2 over 6 here. So we have 6, 7, 8, 9, 10, 11. So this is going to come into 11/6. And that is going to be my answer, because as we take our limit, these 1 over n plus 3, those are going to go to 0, and they're going to, all of these terms are going to collapse, but we were still left with these first 3 terms that didn't. They never canceled with anybody. So my answer for this guy is going to be the series converges, and it converges to 11/6. Okay, so that's how you do a problem like that. Don't feel bad about using a couple lines of paper to kind of make sure you're doing what we're supposed to be doing, but that's why you're supposed to do this. Okay, thank you very much for watching. I'll see you in the next video, and take care until then.